Welcome to the Deep Dive. Today we're tackling some seriously big questions. The kind humanity's been asking for centuries, really. What is time? And what is gravity? We usually think of them as separate things, right? Just fundamental parts of the universe. What if they're not? What if they're, tangled up together in some deep way we haven't fully grasped? We're looking at a really fascinating, maybe even groundbreaking hypothesis today. It comes from some recent research by Pat Rupcom and colleagues. They published in places like the Journal of High Energy Physics, Gravitation and Cosmology, and Applied Physics Research. And they're putting forward this pretty bold idea, calling it potentially a master key to unlocking the secret of the universe. So our mission in this deep dive is to unpack all that. We'll introduce you to this hypothetical elementary particle they're proposing. It might just change how you think about time, gravity, maybe even space-time itself. Yeah, let's unpack this. You might just have your mind blown. It's wild when you think about how our picture of time and gravity has changed, isn't it? Going way back, you had Galileo.
Right. Galileo laid some groundwork. He saw time as this universal thing you could measure. Absolutely fundamental for describing motion.
Then Newton built on that.
He did. Newton gave us this idea of absolute time, just ticking away uniformly everywhere in the universe, totally independent. And his law of gravity, well, that described the attraction between objects with mass, a huge step.
A monumental step, yeah. But it still left questions.
Big ones. And that's where Einstein came in and just turned everything upside down.
First was special relativity.
Suddenly, time wasn't absolute anymore. It was relative. It depends on how fast you're moving relative to someone else. That's where you get time dilation.
Time literally stretching or shrinking, which is already hard to wrap your head around.
And he wasn't done. General relativity came next, linking gravity to the actual curvature of space-time, mass and energy warp space-time. And that's what we feel as gravity.
And it affects time too, right?
Exactly. Time slows down in stronger gravitational fields, so Einstein connected space, time, and gravity. But what's fascinating here is how each step built on the last, yet we still don't have a final answer to what is time, or what gravity truly is at its deepest level.
Which leads us right into this new research. If those big questions are still hanging there, maybe we need a completely new ingredient.
Well, that's the proposal. They're introducing something called the field particle of time, or FPT. They also call them timians.
Timians. Okay, so a new fundamental particle.
That's the idea, a new elementary particle. And it's interesting why they proposed it. They think it solves some long-standing puzzles.
What are its properties supposed to be?
Well, it's got this duality, apparently. It acts like both a particle and a field. It's massless, transparent, and it travels at the speed of light in a vacuum. And critically, they say it's always fused with space. You can't really pull it apart from space to form space-time. It's intrinsically linked.
So it's part of the very fabric.
Yeah.
And they think it's tiny.
Incredibly tiny, smaller than any other known particle, they assume, and it's just uniformly blended into space. Think of it like, well, they describe it as an exotic particle, maybe even with magnetic properties.
Wow. Okay. So how does this fit into space-time? We have the three spatial dimensions, length, width, depth.
And then the fourth dimension, time. This hypothesis suggests timians are basically responsible for that time dimension within the three spatial dimensions. They are like a one-dimensional aspect flowing through 3D space.
And when matter or energy shows up and curves space-time,
the timians flow right into and through that matter, filling up the curved space. They argue this maintains the properties of space-time and crucially creates what they call the reference time for everything that happens.
Okay, reference time. Let's connect that back to time dilation. Einstein's idea that time stretches for moving objects. How do timians explain that? We usually use the light clock analogy, right?
Yeah, the light bouncing between mirrors. If the clock moves, the light travels further, so ticks take longer from an outside view. Time slows down.
So how do timians fit in?
This is maybe the most radical part. They suggest the timians themselves can act as the observer, in a sense. They flow through matter, but their speed decreases when they pass through dense matter. There's a kind of friction, if you will, like wading through water instead of air.
Ah, okay. So denser stuff slows the timians down more.
Exactly. And they argued that this interaction, this slowing down of timians as they pass through matter, is what causes time dilation. Their analysis shows it produces the exact same mathematical result as special relativity's light clock.
Whoa. So it's not just geometry. It's a physical interaction with these timian particles.
That's the claim. It suggests time isn't just an abstract coordinate, but something arising from these physical interactions. Pretty profound, if true.
Okay, let's shift gears slightly. What about ECATR? That famous equation. There's always been that puzzle about needing infinite energy to reach light speed because mass supposedly becomes infinite.
Right, relativistic mass increase. But, when they accelerate protons at CERN near light speed,
In the Large Hadron Collider, yeah.
they don't see the proton's actual rest mass ballooning towards infinity. Its intrinsic mass stays the same. The energy increases enormously, but not the mass itself in that way.
So how do timians explain that energy increase?
The hypothesis here is that the extra energy you pump in isn't increasing the object's fundamental rest mass, its potential energy. That stays constant.
Okay.
Instead, that huge increase in energy, the relativistic kinetic energy, is actually equivalent to the relativistic energy of the timians interacting with that accelerating matter.
So the timians themselves are carrying that extra relativistic energy.
Effectively, yes. And this relativistic energy of the timians creates a kind of opposing force, a resistance. That's the reason it takes more and more energy to go faster and faster, and why you can never actually reach the speed of light. The timians themselves resist it.
That's a completely different way of looking at the cosmic speed limit. Okay, so if timians are behind time dilation and the light speed limit, what about gravity?
Another huge one. We have Newton's force, Einstein's curved spacetime. But this hypothesis tries to explain the underlying mechanism. How does gravity actually work?
And timians are the key again.
They propose that the motion of timians is what transmits energy through spacetime, and that energy transfer is what manifests as gravitational force between objects.
So timians are like energy carriers for gravity.
Kinda, yes. They transfer energy, and that energy gets converted into the gravitational force we observe. And interestingly, their analysis shows this force falls off with the square of the distance.
Just like Newton's law.
Exactly. It matches Newton's law. But there's another twist regarding the gravitational constant, g.
We usually think of that as, well, constant, a fundamental number.
According to this theory, g isn't strictly constant. It technically varies slightly with the relative velocity of the matter involved because of that Lorentz factor, which is tied to the timian's behavior.
But for most things, like Earth orbiting the sun,
Earth's velocity is pretty stable, around 30 kilometers per second, so for practical purposes here, g looks very, very constant. It averages out to that familiar value.
okay, that makes sense. And how does this tie into gravitational time dilation times slowing near massive objects?
General relativity tells us that happens. The timian idea explains it by saying timians actually bunch up, they become denser around massive objects, and remember, timians slow down in denser environments.
Ah, so if timians are denser and slower near a planet or star.
Then any matter passing through that dense timian field experiences more interaction, more slowing, and its own reference time ticks by more slowly, which again matches what we observe. Time slows down in strong gravity, which is usually where matter density is high.
It seems remarkably consistent, tying all these different relativistic effects back to these timians. But is there any way to see this? Any actual evidence beyond the math matching up?
Well, they point to some, let's say, suggestive observations from everyday life. Think about how things deteriorate or age. Low-density things, like a leaf or paper, they break down relatively quickly, right? But very dense things, steel, diamonds, they last practically forever on human timescales.
Oh, I never thought of it that way.
Or even biological preservation, like freezing sperm or eggs. Extreme cold increases density effectively and dramatically slows down deterioration. It slows down our biological clock.
So the idea is that higher density means slower reference time for the object itself.
That's the implication they draw, and it fits the picture of timians moving slower through denser materials, therefore causing time itself to pass more slowly within that material.
My old couch versus a diamond. It's all timians. That's quite a thought.
It is, and they propose a way to test it more rigorously. A thought experiment, really, but potentially doable.
With atomic clocks.
Exactly. You'd need two incredibly precise atomic clocks, synchronized perfectly.
Okay, clock 1 is the control. Standard conditions, room temperature, whatever.
Right. Then you take clock 2 and put it somewhere different. Either in extreme cold, making it denser, or inside a box made of super high density material. Or maybe deep underground, where ambient conditions might also affect timian flow differently.
And the prediction is
Clock 2 should run measurably slower than clock 1. Not by a lot, perhaps, but detectably. If it does, that would be strong evidence that something, potentially timians, is passing through the clocks at different speeds and directly affecting their rate of timekeeping.
a direct test of the timian interaction.
Yes. It takes it from a purely theoretical alignment with relativity to something potentially observable, linking everyday things like density and decay to this fundamental particle.
Okay, stepping back then. If this is right, it really changes our whole picture of time.
It does. The research suggests time isn't just an illusion or a fourth dimension we travel along, it's something physically created by the flow and interaction of these timians. That creates the reference time for everything, and our human perception simplifies that into what we just call time.
And these timians, they're also responsible for gravity. Could they be the graviton?
Yep. That's exactly what they propose. That timians are the particles that mediate gravity, fulfilling the role of the hypothesized graviton. It's an attempt to unify gravity with the particle world of quantum mechanics.
A bridge between general relativity and quantum physics. That's the holy grail, isn't it?
It's certainly a major goal. And they even speculate further, suggesting timians might connect to exotic magnetic phenomena, maybe even related to the magnetic fields seen around black holes.
Really pushing the boundaries there.
And looking even further ahead, they make some pretty wild predictions, like maybe our subjective feeling of time passing arises from timians interacting directly with specific parts of our brain.
Whoa.
And maybe space itself isn't perfectly smooth and continuous, but actually grainy or discrete at the most fundamental level if timians are its building blocks.
Okay, so we've gone from Galileo and Newton through Einstein's relativity to this really mind-bending idea of timians potentially explaining time dilation, the light speed limit, and the mechanism of gravity.
It ties a lot of threads together, proposing this one entity as the explanation.
This deep dive has definitely given us a completely fresh angle on these enormous questions. So here's something for you to think about. If time really does emerge from the physical interactions of these timians, with everything around us, including ourselves, what does that imply about our own experience of time? Could it theoretically ever be manipulated?
Very deep question indeed.
A lot to chew on, right?
Right.
Keep that curiosity burning.